Welcome to AI Frontiers, Advances in Machine Learning Research. On July 31st, 2025, 44 groundbreaking papers were published that are reshaping the field. Today, we'll explore neuromorphic AI that sips power like a hummingbird, breakthroughs in efficiency, interpretability, and robustness, and the seismic shifts occurring in how we build machine learning systems. This presentation will map the machine learning frontier through 5 key sections. First, an overview of the expanding universe of ML applications. Then we'll examine the 5 research themes transforming the discipline. We'll highlight today's most impactful discoveries, take a deep dive into our paper of the day, DynaSwarm, and finally, explore future directions for the field. Machine learning in 2025 has evolved beyond just chasing accuracy metrics. The field is now tackling grown-up problems, achieving greater efficiency with less energy and data, shedding light on black box decisions through interpretability, building systems robust enough for messy real-world applications, and expanding generative AI from artistic creation to scientific discovery. Our first research theme is the efficiency revolution, doing more with less. Sirine Arfa's spiking neural networks achieve 32 times reduction in energy use. Kyoto Index kernel tricks dramatically speed up attention mechanisms. Justin K's Coda slashes annotation effort by 70%. Edge AI now fits in chips smaller than a grain of sand, thanks to neuromorphic computing that mimics the brain's efficiency. The second research theme covers interpretability breakthroughs, eliminating black boxes. Amal Saadallah's SHAP-guided models explain decisions during training. Dinesh Ramachandram's transparent AI manifesto is gaining traction. New tools make models narrate their reasoning processes, while regulatory pressure drives adoption of explainable AI. This builds on technical concepts like SHAP values that quantify feature importance. Theme 3 focuses on privacy and robustness, the shield and sword of modern ML. Salah Vatanka's clipped SGD protects noisy data distributions. Mohammad Karami's OptiGrat trust identifies malicious actors. Byzantine-proof federated learning is now achievable, creating models that detect and resist adversarial attacks while making privacy-preserving AI standard practice. Today's key findings represent major leaps in practical ML deployment. Coda by K and colleagues reduces labeling needs by 70% through active learning. Comnic's causal drift detector identifies problematic features. Use process-constrained RL outperforms GraphRag, while Chang's energy-based unmixing achieves R² greater than or equal to 0.98, creating a molecular microscope for chemical analysis. These breakthroughs were achieved through several methodology trends: neuromorphic architectures for energy efficiency, reinforcement learning for dynamic optimization, diffusion models for data imputation, gradient analysis for security, and hybrid approaches combining multiple ML paradigms. The field is seeing unprecedented innovation in technical approaches. Our first selected paper is DynaSwarm by Huiyi Leong and colleagues, titled Dynamic Agent Routing in Multi-LLM Systems. This work matters because it achieves 45% faster latency and 12% accuracy boost. The key innovation allows agents to reorganize, like a flash mob, with emergent behavior including handshake protocols. Applications range from coding assistance to disaster response systems. The second featured paper is Coda by Justin K's team, Cost-Optimal Data Annotation for Active Learning. Its 70% reduction in labeling effort comes from a smart sample selection algorithm. This makes ML viable for data-scarce domains, with potential applications in medical diagnosis and rare event prediction, where labeled data is expensive to obtain. Our third highlighted paper is DEP MicroDiff by Rabea Tusadia and collaborators, Microbiome Data Imputation via Diffusion Models. This work matters for restoring incomplete biological datasets, applying diffusion models to scientific data. It matches ground truth with R-squared more than 0.95, potentially revolutionizing omics research through accurate data imputation. Looking to future directions, we see several exciting possibilities. Cross-domain transfer of microbiome techniques to climate models, Edge AI 2.0 with chips that can learn and unlearn, the Trinity challenge of unifying interpretability, privacy, robustness, scaling swarm intelligence, and democratizing these advanced techniques for broader accessibility. This presentation was synthesized using GPT DeepSeek-Chat model for research analysis, with TTS narration via OpenAI and visual concepts generated by Grok. While human experts reviewed for accuracy and coherence, potential oversights may exist despite rigorous quality control measures. To stay on the cutting edge, subscribe to AI Frontiers on YouTube for daily research breakdowns like this one. We cover the most impactful ML papers and welcome you to join our community of researchers and practitioners. Share your experiments using hashtag AI Frontiers to contribute to the conversation. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by Archive Preprint Server.